What would you guys say if I measured over 300 watts per channel from an 80 watt per channel rated amplifier? Those are the bench tests we're going to go over in today's video. Hello, my friends. I'm Gene Delasala with Audioholics. And today I want to talk to you about the Denon PMA-A110 Integrated Amplifier. This baby is a beauty. Let me just show you some pictures before we get into the test bench. I love this graphite finish that they have. Really sturdy chassis. Thing weighs a ton. It's like 50 pounds. It's rated at 80 watts a channel, both channels driven at 8 ohms, and 160 watts a channel, both channels driven at 4 ohms. Now, I know what people are thinking. That's not that powerful for a $3,600 integrated amp. Like, I could buy a cheap receiver for $400 or $500 that has a higher power rating. Well, that's true, and it's false. And the reason why it's false is not all amplifiers are rated the same way. There's just, as you've seen in other videos that we've done, and how amplifiers are rated based on the distortion curve really can make a difference in what real world power is available, especially when you're driving low impedance loads. And I want to show you a little bit about the insides of this amplifier. As you can see, it's got a pretty stout amp power section, got 2 separate E-core transformers, 2 very large 12,000 microfarad 71 volt capacitors. Those are expensive audio caps. And the funny thing about that is with 80 watts, you don't even need that much working voltage on a cap. There's a lot of margin here. This power supply has some regulation going on, and we'll talk about that in a little bit. But I love the dual rows of heat sinks, lots of heat sink area. Those are really thick extruded aluminum. And let me tell you something, when I ran my tests on this amplifier, I didn't run them for milliseconds like I do on most receivers. I ran these for minutes, and I never got the chassis burning hot. It stayed very cool, kind of moderately warm to the touch. This guy has more juice than the specs reveal. And I wanted to show you just the build quality. You know, just seeing the standoffs here on the speaker terminals just adds so much rigidity there and so much strength. I just love these little meticulous details that you see here. And this only has 2 speaker outputs. You can only plug 2 speakers in. It's a 2-channel amp. Doesn't have an external preamp output, so you can't use external amplification with this, but you can use it as part of a home theater system if you want to take a receiver preamp outputs and plug it into this and use it as a separate 2-channel system. That's available to you. You've got 3 optical inputs and 1 coaxial input. And then you have a USB DAC, the asynchronous input, so you could plug your PC right into it and bypass all the circuitry in your PC and take advantage of the quad differential DACs. This product is kind of like a throwback to the 2005 era, the flagship stuff that Denon used to make in their premium factory. This is, incidentally, this is made in Shirakawa, Japan, where their best products have been made. This product has the Burr Brown 1795 DACs, quad differential. That means there's 4 DACs per channel, and they parallel them up to reduce the current noise. And you'll see in my measurements, this is a really clean integrated amp, not only for the power, but also for its DAC section. So I'm going to share my screen with you. That way I could show you guys more about this test report. And this test report's available right now on Patreon, on our Patreon channel, patreon.com/audioholics. I will be making this available in the written review as well. But if you wanted to see that immediately, you have to become a patron to see this, and you can follow along with it. So let me open up this test report. So as you guys know, I test power in 3 different ways. I do continuous full bandwidth from 20 to 20 kilohertz at 8 ohms and 4 ohms. I do the 1 kilohertz power sweep versus distortion. Those are the kind of tests the print magazines used to do, so I keep that there. It's important to do. You can really check the capabilities of a power supply by doing these tests, especially on multi-channel amplifiers. And then I do the dynamic power at 1 kilohertz CEA 2006 burst test method that simulates kind of dynamic range that you get, the peaks in music. So we like to look at that there. So going to the first graph, again, this is rated at 80 watts a channel. I basically measured at rated power the frequency response, as you can see here, and it's flat out to the 3 dB point of 62 kilohertz, which is, way above audible range of 20 kilohertz. It's a very linear amplifier. This is at full rated power, both channels driven. And then I plotted distortion on the same graph, and it's under 0.02% up to 20 kilohertz, both channels driven. So this beats its spec. And then I reran this test. I don't show all my measurements here because it's just too much, but I reran this test at 4 ohms, both channels driven, and I got actually a little bit more power. I was able to turn it up a little bit. I got 165 watts a channel, both channels driven, and I still maintained under 0.1% distortion under that test. So this is hitting its rated power with ease, very conservative rating. The next thing I did is, I know that Audio Science Review has become very popular, and Amir's doing a great job over there with all of his measurements. So I wanted to have the ability to put some measurements that are apples to apples from what he does versus what I do. He likes to do SINAD, and that's basically the reciprocal of THD plus N, the signal noise ratio plus distortion. So what I did was I plotted a SINAD response at rated power at 8 ohms, and I got about 93 dB within its power band before it started clipping. That's a really good measurement. It's not, state of the art in terms of the very best, but it's certainly below audibility. That's very low distortion, as you can see here. I was at like 0.002% THD plus N. That's very clean, very good there. Source Direct actually helped it. It gave me about a 2 dB advantage as opposed to non-Source Direct. So definitely use Source Direct if you care about the very best fidelity, and that bypasses your tone controls and other circuitry in there. So next up, I did a power sweep versus distortion with both channels driven at 8 ohms. And you could see here, even though it's rated at 80 watts, at 0.1%, I got 91 watts, both channels driven. And at 1% distortion, I got 96, 97 watts. And I consider the 0.1% kind of a fidelity firewall. So if you're under 0.1%, it's usually not audible. It really depends on the level and the type of tones that you're using. But generally speaking, 0.1% or below is clean. It's not something that's not audible. When you start getting to 1% distortion or higher, you can start seeing clipping on a oscilloscope. That's bad. You don't want the power to be rated in clipping. So right there, we met spec or exceeded it. I reran the test using 4 ohm loads, and we got 171 watts, both channels driven at 0.1%, and 184 watts, both channels driven at 1%. So that's some good power there. And you can see how very linear this is until it gets to the knee here. This is a good power versus distortion spec. This amplifier is well behaved. It's not doing any funny current limiting that you would see in some of the cheaper receivers that are rated at even more power than this. So this is what I like to see, this kind of a curve. It's very good. Now, again, I didn't show all my graphs, but I reran this test using 2 ohm loads. Ordinarily, I would never test an amplifier at 2 ohms, but the fact that this amplifier was able to dissipate the heat and not act as a space heater like you find in most of the AVRs today, I ran this thing at 2 ohms, both channels driven, and I got 218 watts at 0.1%, 253 watts at 1%, both channels driven. So if you have really low impedance speakers, this is going to be just fine. This amplifier can handle that all day long. This is where those 140 or 150 watt receivers, the AVRs that are rated higher than this, will fall apart. They can't be driving 2 ohm loads for any kind of sustained output. So that's the one big advantage of this integrated amp, is it's got a lot of heatsink area. It's got 2 separate power supplies, and it just has plenty of margin here. So the interesting thing I ran when I did the dynamic test, I didn't see a whole lot of more power under dynamic conditions as opposed to the power sweeps. And that's very rare. I usually see, a couple of dB more power when doing these dynamic burst tests. And I checked with Denon on that, and they actually said that they were able to replicate these results. And they claim that this is expected design to eliminate the effects of power supply regulation due to output current. Specifically, the voltage amplifier stage, it's optimized and controlled to be driven constantly for rated power. So they really optimized the power of this thing for 8 and 4 ohm loads, and just to keep it from any type of sag or anything like that. They did a good job here on sustained power. Like I said, I was able to run this thing for minutes at a time, had no problems. The interesting thing is I ran this dynamic power test at 2 ohms and actually did get more power. And they said under that load condition, they couldn't guarantee the regulation for a very low impedance. So in this case, we actually got more power. This is where we got 330 watts, both channels driven at 2 ohm load. That's a lot of power. That's a lot of headroom for an 80 watt per channel amplifier. I just thought that would be kind of an interesting test. It just goes to show you that this amplifier could drive 4 ohm speakers all day long. It can handle it with dips down to 2 ohms. So if you have one of those old speakers like an Apogee or the Carver ribbon speaker, I'm sure this amplifier will easily drive it without any issues. So I wanted to show you how clean it is. And what I do with that is I run FFTs. Now I know when Amir does his FFTs and his SNR stuff, he does it at 5 watts. I do mine at 1 watt. You could scale that if you really want to. All you have to do is you take 5, you take the log of that times 10. That's basically 7, and you just have to add 7 dB to my measurements to correlate to a 5 watt rating that Amir does. So we look at the FFT here, and the FFT will show you of any bad behavior. This is a very precise measurement. You can see the noise floor here is down below 120 dB. There is some power supply hum here. This is inaudible. This is leakage in the transformers, but it's down, in the mud below 90 dB. Never have I once heard any hum at all. But the cool thing about this is with 1 watt and 1 watt, I know Past Labs always talks about, the first watt is what's most important. This is a very low distortion amplifier at very low power. This must be operating in a high class A bias, because I measured the third order harmonic 103 dB below the fundamental. That's really low. That's really in the weeds. That's the kind of stuff you like to see. That's better than most AV receivers that I've measured. So that's just really clean. Now, what happens with a lot of AVRs is when you run them at full rated power is their FFTs get really nasty and they just don't look good. In fact, I've seen high-end amplifiers that looked really bad under full power just because they didn't have enough feedback in the design. This guy is rated at full rated power. We're down to 91 dB. Again, this is in the weeds. It looks big here because the signal here is so large. We're at over 30 dB V here. So the differential on the second order harmonic is still 91 dB below the fundamental. That's really good performance. I'm happy to see this. And that's part of the reason why this is an expensive amplifier. I mean, they try to do the very best they can with Class AB design. And I think they've mostly achieved it here. So this doesn't have preamp outputs, but it does have a recorder output. I guess if you go to plug a tape player in, or if you just want a fixed voltage output of 2.2 volts, just wanted to show you how clean this was with a 0 dB FS input signal based. I used the coax input. I measured 2.2 volts RMS out, and I got 112 dB the third order harmonic below the fundamental. That's really clean there. Glad to see that. Too bad they didn't put a preamp output on this. Hopefully maybe they do that in the next generation or something. So I didn't want to forget about the Phono people, and I'm a big fan of Phono myself. I went and I downloaded the RIAA equalization curve into my Audio Precision so it could linearize the response when I measured the Phono outputs, and I measured the moving coil and the moving magnet. This is the moving magnet here. As you can see, it's a very linear bandwidth out to, past 20 kilohertz. The distortions is pretty low. Unfortunately, I didn't zoom in my graph when I saved it, but I remember the distortion was under 0.05% THD plus N. And the signal to noise ratio under this test condition is 89 dB A weighted, which is excellent. As you know, Phono does have more noise than your regular inputs. And it did really well here. It's a very quiet Phono stage. So then I ran the moving coil. Obviously, moving coil is a much more sensitive output. the gain's much higher because the input sensitivity is much lower. You're dealing with millivolts, 2 millivolts. And I reran the test here, and I got, again, very good results, 0.05% THD plus N. The bandwidth was very linear. The signal and noise ratio wasn't quite as good, obviously, because it's moving coil, and it was still 80 dB, which is excellent. And let's see what else I ran here. So I ran the signal to noise ratio. I wanted to do dynamic range on this. And what I did was I ran a 0 dB FS input signal, and I adjusted this output at the speaker level. So it read 1 watt, obviously, because I don't have preamp outputs. And I got almost 96 dB, 94, 96 in one channel, 95 in another. Is about a dB difference. I think one channel was closer to part of the power supply, which made this a little bit of a difference. Incidentally, I sent this entire test report to Japan and Denon, and they looked over all my data, and they actually went and remeasured the entire system to get correlation to what I had, and they validated my results. I think that's really awesome. It's very rare when you get a company that will spend that much time looking over your test results, checking it themselves. And I always get my stuff checked before I publish, just because I could make mistakes. I had some issues with one of my measurements on here, and if I didn't check with Denon, I would have reported a measurement that wasn't accurate. So I'm always glad to do that. Got good ratings here, the SNR. Then I went and I rated it at full power. So I took a 0 dB FS signal and I measured it at full rated power, unclipped. And we got, with a 24-bit signal, we got 114 dB A-weighted. Really, really quiet there. Now, I don't do the signal and noise ratio test that's part of the AES standard. I think it's okay for DACs, but it's weird that they apply this for amplifiers. When Denon did this test, they got like 120 something dB under this method. And the way they do that is they put a minus 60 dB FS signal on the input, turn the gain all the way up on the output, measure the SNR, then add 60 dB back to that calculation. And I just think that's weird, because if you add 60 dB back, that puts you at a 0 dB FS input signal. That means with the volume at maximum, that amplifier would be in hard clipping. It clips when you get about halfway up at 0 dB FS. So to say that you're getting 120 dB signal and noise ratio is not accurate, just because the amplifier would clip under those conditions. But suffice it to say, it's a very quiet amplifier. I don't have any problems with it. So I just want to show you the power table. I'm going to bring it down here more. So I ran 2 channels, continuous full bandwidth, 85 watts at under 0.1% for 8 ohms, 165 watts for 4 ohms at 0.1%. Here's my power sweep data, 96 watts, 2 channels driven at 1%, 91 at 0.1%. Then I did it for 4 ohms at 1%, 184, 171 at 0.1%. And then I did it for 2 ohms, and this was, this is a nice welcome surprise here. Got 253 watts, 218 watts at 1%. The ideal amplifier would double down with having load impedance, and this is pretty close. So if you think about it, we got 85 watts at 8 ohms versus 253 watts at 2 ohms. We got about a 3 factor of power. I mean, it's really hard to get an amplifier that can keep doubling down. You're going to need one that's much bigger and heavier when it comes to a linear A/B design. But the fact that this was driving 2 ohm loads without issue is just good. It's a good thing in my book. So the last measurement, and this is the measurement I had an issue with originally. I saw a bigger difference in the channel-to-channel isolation using my crosstalk test. I originally thought it was about a 20 dB difference between channels, but then Denon did the measurement and they said it was around 10 dB, and I realized that my cables were just too close together, the speaker cables, and it was messing up my channel-to-channel isolation. So I went and I redid it, and you can see here the channel that's closest to the power supply allows a little bit more ingress and noise as opposed to the channel that's further away. But we're still talking, down in the mud. We're talking about minus 60 dB of isolation at 20 kilohertz, which is really good, and minus 85 dB at 1 kilohertz. Definitely not going to hear any kind of crosstalk. You're going to have good stereo separation using this amplifier. So I hope you found these measurements useful. The bottom line on this amplifier is, yes, it's expensive. Yes, it's rated very conservatively, only at 80 watts a channel, but this is real power. This isn't like the AVR today that tells you it's 140 watts a channel, and then you go and try to drive a low impedance load and it either shuts down or overheats or just doesn't have the kind of finesse that this amplifier has. And that's exactly what I heard. So I put this amplifier on my Revel F328BEs, which you see in the background. I played it on the Paradigm 800Fs. I'm going to be doing more testing. I'm going to be playing it on some Polk L800s as well as some Bowers & Wilkins 704 S2s, wide variety of speakers. And so far, I've really liked what I heard. And my reference in this room is the Anthem STR separates, which is a lot more expensive. So all I could say is I'm really happy to have in my possession one of these amplifiers. I know Denon's only doing very limited production run of these. I think maybe for a year or two, and then they're not going to be producing it anymore. And it's the closest thing you can get to a hand-built amplifier by a major manufacturer. So in my next iteration of reports here, I'm going to also look at the A110 SACD player. That'll be coming up. So I hope, again, you guys found this useful. Tell me down below, are you a fan of integrated amps? I love integrated amps. And it's not just because it lacks a tuner. I mean, honestly, who uses an AM or FM tuner anymore? Really? I mean, I never listen to radio. But the fact is, usually when you get an integrated amp, the companies take them more seriously. They put a little bit better components in it. You get a little bit better power supply. And they're one of my favorite category of products. So it was a pure pleasure to review and measure this. It kind of reminded me of the Marantz PM11S3 that I've done a couple of years ago. That was a little bit more of a powerful product. It was more expensive. It was like $5,000. That was a beautiful piece. But this is, this has kind of many of those attributes, and it just feels high end. If you actually, just touch the chassis, it is kind of audio jewelry, but it actually is good audio jewelry because you got good performance and you've got the great looks that match it. So I hope you guys found this useful. Don't forget about our Patreon channel at patreon.com/audioholics. And until next time, my friends, keep listening.